So, in triangle MNP, we want to find the measure of angle N. So I'm going to just put a little blue part here. This is what we want to find. Okay? Now, notice we have an angle and an opposite side. So we can use the sine law. But if you wanted to find angle N, you would need its opposite side, and we don't have its opposite side. So we can't use the sine law for angle N because we don't have the two things that go together. But if I look at this question, can you see that we could figure out angle P? And if you found angle P, then they're going to add up to 180. So this is a little bit harder than the last question because we can't find it directly, but we can say, and this is the strategy in trigonometry is if you can't figure out what you can want right away, see what else you can find. And as soon as you find something else, then look at it again, and it'll probably be easy to find what you have left. So in this case, we have these two that are opposite. That's important for the sine law. And the only thing that we have other information for is with the 10 centimeters, which would go with angle P. So if I wanted to find angle P first, I put that in my numerator. So notice this time, I put the sine on the top. Right? So if you're trying to find a side, put that on the top. If you're trying to find an angle, put that on the top. That's why there's the two forms of the sine law. And it's going to equal, well, the only thing that I have connected together is the 92 and the 118, so that 92 would go in the numerator and the 118, 11.8 would go in the denominator. So again, angles go with opposite sides. How do I get sine P by itself? Multiply both sides by 10. And this is where things, they could get a little bit interesting. Okay? And I'll show you why. I'm going to just type in this to get it as a decimal so we can look at it. 10 times sine of 92 degrees divided by 11.8. 0.847. I'm actually going to write, because I don't want to, just put dots. I'm not rounding early. In triangles, in the past, when you use SOHCAHTOA, you could never get angles bigger than 90 degrees. Because SOHCAHTOA, one of them is 90, and the other two have to add up to 90. But now that we're having triangles that aren't 90 degrees, is it possible to have an angle bigger than 90 degrees in a triangle? Yes, it's called an obtuse angle. So we have to be a little bit careful, because that ambiguous case sometimes shows up here. How do we recognize it? Well, what we learned in the first part of our unit is if sine is positive, according to the CAS rule, it could be in quadrant 1 or quadrant 2. What would we need to do? We would need to find the reference angle, right? If sine is positive, could be quadrant 1 or quadrant 2. I'm going to draw a little picture here. There's an angle in quadrant 2. There's an angle in quadrant 1. And we're going to see what are the possibilities. So how do we find a reference angle? We always do sine inverse of the positive value. It's already positive, so I can just go to my calculator, and I can go sine inverse, just select this number, all of its decimal places, and I get a reference angle of 57.88. So I'm going to write it this way, that my reference angle is 57.88 degrees, and that would mean these are my reference angles, and this is my angle theta, or sorry, angle P in this case, that P could equal 57.88 degrees, or, should have done 3 decimal places, but can you see in this quadrant 2, it'd be 180 minus 57.88. 122.12. Are both of those answers possible? Or is one of them impossible? Look at our picture of our...
Wait, would the 122 not be possible?
Because you can see if you put 122, you get more than 180 degrees in your triangle. So, sometimes the second one will be possible. And there's actually 2 answers to this question. But in our example, there's only the one answer. So angle P is 57.88, and then does it make sense that you could now find angle N, which is what we wanted to from the beginning. And angle N is going to equal 180 degrees minus the 92 degrees minus the 57.88 degrees. I'm going to go to my calculator. I'm going to go 180 minus the 92 minus, and I'm going to take all the decimal places. 30.119. I like to keep 3 decimal places, then do a read at the beginning. What do they want us to round to? The nearest degree. So angle N equals 30 degrees. If you forget the degree sign on an angle, you lose a half mark for forgetting your units. Technically, you're going to learn next year that if you don't write the degree sign, it means radians. Okay? And what is a radian? 1 radian is about 57 degrees. So if you want to know, if the answer was supposed to be 30 degrees and you forgot the degree sign, you're technically writing about 1,710 degrees. Right? That's insane. You're off by a ton. Right? So if you forget the degree sign, technically you're writing radians. We don't even know what radians are yet. We'll learn about them next year. But 1 radian is about 57 degrees. So then you're off by a lot.
And what are you even using it for?
All higher level math uses radians. Calculus only uses radians. Because it actually makes more sense. But it's harder to comprehend early on. So when we start math, we learn degrees because they're easier to think about. Radians all deal with stuff like pi. You know how your circumference is 2 pi r? There's 2 pi radians in a circle, as opposed to 360 degrees in a circle. So you're going to learn about that next.
I know you don't.
So this one, a little bit more complicated when solving for, the angle, because your cast rule and your reference angles will come into play. Okay? And there's going to be times that you could get 2 possible answers. In this situation, we didn't. But it could be that you get 2 possible answers. Okay? The textbook is sometimes fussy. Sometimes the textbook will say, we drew you a picture. And if in the picture you can see the angle is acute or less than 90 degrees. You know those words? Obtuse, bigger than 90 degrees. Acute, less than 90 degrees. So sometimes the textbook will say, well, based off the picture, you can see it's less than 90 degrees. But then they're going to give you somewhere they don't give you the picture, and then you have to consider both of the angles as possibilities. Okay, circle question number 4. now I'd like you to take 5 or 10 minutes to get good at the sign law and its setup.